Hey everyone, welcome to today's lesson. Today's lesson is going to be about solving a 3 by 3, a 3 variable system of equations. You are used to doing 2 variable system equations like an x and a y that you did in IM1, and we actually just reviewed 2 weeks before we left school. Okay, so now we're doing a 3 variable um, system of equations. Um, and later on, I think you'll actually have practice with a 4. Okay, now initially, yesterday, I had the plan of showing you the manual way of doing this. Okay, but if you read this area right here, I actually retracted that statement, and I'm going to teach you the simpler way, the automatic way, so to speak, using your graphing calculator. It's much simpler. Yeah, I think you'll enjoy the automation of this. Uh, First of all, be sure even before you watch this video, before you continue watching this video, watch today's video tutorial on how to use a graphing calculator to solve this. Because if you don't watch this video, okay, the tutorial, then you will not know how to do this slide and anything afterwards. It's a very straightforward tutorial. It's totally within your skill set to learn to learn the skills, learn how to use the graphing calculator, I should say, in order to solve this. Okay, so please watch the video, the tutorial first before you continue on. Okay, um, now, so again, based on if you watch this, you have to have watched this tutorial by now. Um, you should know that you enter this equation into your calculator as a 3 row by 4 column matrix, and it's going to be 1, -1, 2, -3, 2, 1, negative, whoops, not negative, 2, I meant -1, 0, -1, 2, -3, 7. And basically, I get those numbers from the coefficients here, 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 and I wrote it all there. So that's what you're going to enter in your calculator, okay? And you're going to store it into, okay? You're going to store this into A, and remember, you're going to do R, R, E, F, okay? And this is a matrix, so it has brackets, and then you're going to go A, okay? And it should spit out something that looks like this, okay? And then this is interpreted as this answer here, okay? All right. So this is your x, 1x equals to -2, um, and I highlighted the wrong thing here. I should have highlighted this. I should highlight this 1 right here, and this means 1y equals to 7, 1z equals to 3, and that's how you interpret it. Okay? Now later on, by the way, in around probably 3 minutes or less, you're going to have a situation where you're going to need a placeholder, giving you a little heads up. Let's say, for example, nothing was written over here originally. Okay? That means you need to put a plus 0z there as a placeholder. Okay, again, I'm making this scenario up. This is not part of the original problem. And if you put a plus 0z there, then that means this is going to be 0. Okay, so I'm going to give you a problem later on where you're going to need to put placeholders, and there are going to be some more challenging placeholder problems, which is still within your skill set, where they'll cross that off, they'll cross this off, they'll cross this off, and you would have to put a 0x here and a plus 0y there, which means this would be 0, this would be 0. Okay, and then you do the same thing, hit up RREF. Okay, all right, now moving on. Okay, now here's a situation where you have infinitely many solutions. Okay, so do this, put this in your calculator as normally, okay, as you would normally, and then use RREF. Okay, and then you're going to get a row of zeros, okay, on the bottom, a row of all zeros. And if you get that case, if that's the case, then that means that you have infinitely many solutions. Okay? The way I like to think about it is that this is 0 z. Let me use red. Okay? 0 z. Okay? So that means you get 0 z equals to 0, and you divide both sides by but you can divide both sides by z if you want, and you will get 0 equals to 0. And you should know from IM1, okay, that if you have a number equal to itself, that means infinitely many solutions. Okay? Going along the same lines, let's go to this example, okay? Start this off as normally. You actually don't have to put these into your calculator, okay? Uh, you can just listen in right now and just trust that you're going to get this as your answer if you were to put it in your calculator. If you get a bottom row of zeros, okay, so this should say bottom row, okay, bottom row. If you get a bottom row of 0, 0, 0, and then 1, like you see here, then that's going to be no solution. Because essentially what that means, okay, essentially what that means is, okay, let me bring out my arrow here, okay, right there, and right there, and move this over. Essentially what that means is this. You get 0z, okay, 0z equals to 1. If you divide both sides by if you divide both sides, oh, and excuse me, and 0 times anything is going to be 0, and you're going to get 0 equals to 1, and that's not a true statement, okay? So 0 does not equal to 1, which means no solution, okay? And over here, I should have explained it as 0 times z is 0, okay? I explained it earlier a little differently, but let's just say 0 times z is 0, just like 0 times z is 0 here. Just be consistent in both explanations. Okay, so this is a situation when you get a bottom row all filled with zeros is infinite. You have a bottom row of 0, 0, 0, and 1, and that's no solution. Okay, so I'll write infinite solution here. Now, moving onwards. Okay, now the previous three examples, you have a 3-row by 4-column matrix. In this case here, okay, you have a 3-row by 5-column matrix. So I just want to plant the seed in your head that it's not always 3 by 4. I mean, it can be anything. You know, it can be 3 by 5 in this case. It can be 2 by 3. It can be 2 by 3, 2 by 4. Okay, you just have to count out the rows. In this case, it's 3. Okay, 1, 2, 3, and then columns 1, 2, 3, 4, 5. Okay, it's like a tic-tac-toe grid where you start drawing the horizontal lines first. And the horizontal lines are your rows, the vertical lines are your columns. Okay, so remember, it can be any combination of rows and columns. Okay, now I planted the seed earlier about placeholders. Let's look at an example here with placeholders. Okay, here if you look here, there's x's, y's, and z's. Okay, yet this one only has x's and z's. This one only has y's and z's. Okay, and this one only has x's and y's. Okay, so I want to show you what to do. Okay, I'll copy and paste this guy. I'll put it right over, running out of room a little bit here. I'll squeeze that, perfect. Okay, so let's look at the blue right here. Okay, and let's go ahead and look at the blue. Okay, this one is missing a placeholder of 0, y in the middle here. Okay, that's missing a 0, y, so I put it right there. Okay, this is missing a 0x to the left, so I put it there. This is missing a plus 0z over here, okay, or right after the y, in between the y and the equal sign, I should say, right there. So I have these placeholders that I put here, okay, and then once I have these placeholders in, okay, I copied the blue into the red, I put these green highlights into the graphing calculator as you normally would, okay, and hit up RREF, okay, all right. So that concludes just the examples, okay. Next on the screen, you're going to see some problems I want you guys to do, okay. So if you need to revisit some examples, just press rewind, but here are the problems that I want you guys to do. Okay, first off, I want you guys to do the green highlights first and then yellow second. Okay, the yellows are the ones that need placeholders, by the way. Okay, you'll see it. You'll see that you're gonna need some placeholders. Okay, so greens do this, this. Just hit it up on your calculator and just write your answer as x equals 2, y equals 2, z equals 2, or infinite solution or no solution. Okay, so there's really not that much work to be shown. Okay, and then go ahead, do 5862. This right here, okay, is not a 3 by 4 matrix. Okay, you can pretty much figure out what this one is going to be. Just again count the rows. Okay, again count the columns. Boom, boom, boom. Okay, boom. Do the same thing for 62. 55, these yellow highlights are going to need placeholders. Okay, so put the placeholders in the proper place. Okay, and just write down the answer. Okay, whether it's actual numbers for the answers or it's infinite or no solution. Okay, folks, that concludes today's lesson. Okay, again, be sure to watch that video. Okay, that tutorial video on how to put these in your graphing calculator. All right, thank you very much for listening in, folks. Have a good rest of the day.